All right, so for section 4.7, we're going to talk all about inverse trig functions. And so, something that we want to talk about when we talk about inverse trig functions, inverse here just means that it's the opposite, so addition has subtraction, multiplication has division. So inverse trig is just how we undo trig functions. Okay? And for that, so for trig functions, or I shall say inverse trig functions, we have a notation that we use arc, or we just take the trig function and raise it to the negative first power. Okay, so this is how we denote inverse trig. So as an example, so for inverse sine, we would say that y is equal to the arc sine of x, or we would say that y is equal to the sine of raised to the negative first power of x. Okay, either way that you want to use the notation is great with me. I am not picky. I usually stay with the raising to the negative first power, just out of habit over years. But you're welcome to use whichever notation that makes you happy. The book does seem to want to use arc more, so it may be good practice for that. But if you see me write it to the negative first power, that's why. Okay, and so the definition of, and this applies for our other inverse functions also, but the definition of this is that y is equal to the arc sine of x if and only if that sine of y is equal to x. Okay, so let's talk about how that how that applies. So let's say let's do the forward direction of this. So let's say that the arc sine of x is equal to y. Then if I take the sine of both sides, and I'm going to have to be careful here with my notation. So I say that if I take the sine of both sides, then sine and arc sine are inverses, so therefore they quote unquote cancel, right? And so then x is equal to the sine of y. Okay, so that's how we get rid of arc sine, is just by taking the sine. Vice versa, going in the other direction, to get rid of sine, you just take the arc sine or the inverse sine. Okay. And our other inverse trig that we will use are things like, and they're all things that we've already discussed, but we have arc sine, which we've already talked about. We also have arc cosine, and we have arc tangent. Okay, and again, just think of these as, if you were multiplying by 3, you would divide by 3. If you were if you were adding 4, you would subtract 4, right? That's all this is. Okay, and so an example problem here that I want to talk to you about is what I feel like is a pretty good one. So let's say that we want to define the arc tangent of the square root of 3 over 3. Okay, and I don't know what that is right off, right? So I'm going to say, well, we'll say it's x. All right, so I'm going to now take the tangent of both sides. So I'm going to take the tangent of the arc tangent of the square root of 3 over 3 and say that it is equal to the tangent of x. Okay, well, again, arc tangent and tangent undo each other, so those go away. So I am left with that the square root of 3 over 3 is equal to the tangent of x. All right, normally, and in this case also, we need to reference our unit circle. Okay, so when you get sine and cosine, there's a good chance that the value of this will just be on the unit circle. However, for tangent, since it's an opposite over adjacent situation, then I can't just blatantly look at the unit circle and say, okay, well, that's obviously that. Now with practice, of course, obviously you will get there. Okay, so I'm gonna start with my 30-degree mark, or my pi over 6. Okay, this is kind of a guess and check until you get comfortable. So the coordinate for that 30 degree is the square root of 3 over 2 and 1/2. Okay. Now when I look at the unit circle, this is my x coordinate and this is my y coordinate, right? Y represents up and down, x represents left and right. So let's do that in a triangle. Okay, well, if I could draw a triangle. Okay, so I've got my triangle. This degree marker always represents this portion here. The pi over 6 is just the radian version of it. All right, so my x would be my horizontal, so my square root of 3 over 2. My y is my up and down of 1/2. Okay, so now to find tangent of this 30 degrees, all right, would be equal to my opposite 1/2 divided by my adjacent square root of 3 over 2. Okay. Well, I have a complex fraction, so I just need to multiply by the reciprocal of the bottom. So this is the same thing as saying 1/2 times 2 divided by the square root of 3. Okay. 2's go away, and I am left with 1 over the square root of 3. Okay. Now, unfortunately, this is not an acceptable answer, 1 over the square root of 3. However, to make it an acceptable answer, I just multiply it by the square root of 3 over the square root of 3. So I have 1 over the square root of 3 times the square root of 3 over the square root of 3. Okay. The square root of 3 times square root of 3 is just the same thing as the square root of 3 squared, which is just 3. Square root of 3 over 1 is square root of 3. And as you can see, there is my answer. Okay, so what I can say is x is equal to 30 degrees, or in this case, because we want radians, we'll say pi over 6. Okay, so my answer for this would be pi over 6. All right, you can use the same thought process to solve things for sine, cosine, right? And without all this extra algebra, because the answer will either be a square root of 3 over 2, or 1/2, or 2, or square root of 2 over 2, something like that, right? So just remember that your horizontal is your x, or the bottom of your triangle. The vertical is the y, is the 1/2. Again, it will take trial and error to get these correct. But once you do a few, you'll kind of get the idea. So this concludes section 4.7. I'll post this with an email also, but 4.6 doesn't need a video because it's all in the graphing calculator. But if you do have any questions about 4.6 or 4.7, please feel free to email me, and have a great rest of your day.